have a go at this in your own time. I'm going to add an overlay here so I can talk through what I'm doing. I'll use my standard approach. Are there any fractions? Well, yes there are, so let's get rid of those. So I'm going to times by 5x minus 3. By which I mean I'm going to times both sides by 5x minus 3, so it will cancel on the left hand side and disappear, and it will end up as 2 times 5x minus 3. Let's deal with that. Are there any brackets? Yeah, well I just made some, so I better deal with that. So 1 equals 10x minus 6. Are there any more brackets? No, let's deal with that. Is it an x or an x squared question? Well, I can't see any x squared, there's just an x. So let's call it an x question. I just need to rearrange it until I get x equals. Let's add 6 to both sides. So 1 plus 6 is 7, so right, that's a 7 equals 10x. I'm going to divide the top and bottom by, let me start again, I'll divide by 10, because I want to get x on its own. I'm trying to move all the numbers away from x, so that's 7 over 10 equals x. You could leave that as your final answer. I would think that's perfect. You might just really be thinking, oh, I want to write around the other way, in which case you can do that if you want. Anyway, there we go, done it. So have a go in your own time. So this is the approach I'm going to use. Are there any fractions? No, dealt with that. Are there any brackets? Yes, let's multiply those out. So that gives me 12 plus 3x, that hasn't changed. 3x squared rather. 15x plus 30. So that's dealt with that. Is it an x or an x squared? Well, I can see an x squared. I can also see an x as well, but the main thing is I can see an x squared. So we'll make it equal to 0. I'd like the x squared term to be positive, so I'm going to move the things that are on the right hand side. So I'm minus 5x from both sides, and I'm going to minus 30 from both sides. So I'm going to be risky, and I'm going to do both things at once. 12 minus 30 is minus 18, so that's minus 18. The 3x squared just sits there. Minus 15x equals 0. I'm just going to rearrange that. So this is one of these things you just kind of do. It's not on the list it's not on my little list on the right hand side, but we try and sort of keep that as short as possible to make it easier to remember. Okay, anyway, so I've rearranged it so it looks more familiar, which I like to do because it makes it easier, I think, because it helps my sort of visual memory. Factorize. They've got a 3 in common, because the first thing you do is ask, is there anything they've all got in common? So I can take that 3 out. Now, we didn't have to do that. We could have just divided by 3, which meant it would have just disappeared. So just literally, you base it, and you could possibly have just written there divide by 3. It's up to you. Both work. Anyway, so let's pretend that we just divided by 3 and we can't see anymore. Let's factorize. We want the first two things multiplied together to make x, the second two things multiplied together to make 6, so it's either 1 times 6 or 2 times 3. You can use trial and error in your own time if you like. I'm just going to get a move on, because this is mainly about solving, not factorizing. So that's the answer. So that makes x equal to minus 1 or x equals 6. So to solve this, let's get rid of the fractions first. I'm writing here my usual approach for solving equations, but that doesn't have to be exactly in that context. But anyway, I'm going to times by 3, because it will get rid of this fraction here. So that gives me 2x plus 1, because it's just cancelled there with the divide, plus 3 times x minus 5, divided by 2, because I'm timesing by 3, it times is the top of the fraction but not the bottom, because it's making it larger, and 4 times 3 is 12. Now let's times by 2 to get rid of the other fraction. So that'd be 2 times 2x plus 1, plus, this is just 3 times x minus 5, because the timesing by 2 is cancelled with the 2 that was on the bottom there, and that makes 24. Let's multiply out the brackets, because, well, lots of reasons, but one reason is it's the next part of my standard approach. That's one way of thinking about it. Minus 15 equals 24. Is it an x or an x squared? It's an x type question. Whoops. It's an x type question. It's not an x squared. So it just means we need to rearrange it until we get x on its own. So that'd be 7x minus 13. So I'm initially doing a bit of simplifying. And I'm going to add 13 to both sides. So 7x equals 27, 37. So x equals 37 divided by 7. Have a go in your own time. First of all, let me just check you didn't do some. Let me just check. This is wrong. No! You mustn't just cancel the two x's. You can't do that. Because what we've got here is we've got a divide, because the fraction means divide. We've got pluses, and you can't cancel pluses with divides. It just doesn't work. You can only cancel divide and times, or plus and minus. So you've got two routes to go here. We could simplify x plus x plus x into 3x, but let's pretend we haven't spotted that yet. Let's get rid of the fraction. Times by x plus 2, which means you've got x plus x equals 5 times x plus 2. Let's get rid of the brackets. X plus x equals 5x plus 10. At some point we're going to notice there's an x plus x, and we're going to say, hang on, why don't we just simplify that? So probably would have been better to do that straight away, but we just pretended we hadn't spotted it, because the point is you can do it any way you like, but the sooner you do it the better, so it would have been better to have done it earlier really. There's no x squared, so it's just an x question, so we're just going to rearrange it into x on its own. So I'm going to minus 3x, because I'd like to take the 3x over to where there's more x's. Let's minus 10 from both sides, because I'm now pushing all the numbers away from the x. That's supposed to say minus 10 on the left hand side there. And then I'm going to divide by 2, which gives me a final answer of minus 5 equals x. So I'll stick my overlay on here so that I can talk through my answer. Are there any fractions? Nope. Are there any brackets? Nope. Is it an x or an x squared? It's an x squared. Is it equals 0? Yeah, wow, got all the way to there. I still think it's good to go through our checklist, because it means you're doing every time you're really kind of getting that method down, getting it really good. Let's factorise. We want to make 11x squared. Well, 11 is a prime number, so basically it's going to be 11 and then a 1. We also don't write the 1. By the way, you might be thinking it could be root 11 root 11x root 11x. That's basically when you're doing like a sort of where it's sort of a complete the square. I just thought I'd reference that in case you were thinking, so that's why I'm dismissing that. Don't worry if that didn't make any sense. It's a prime number, so it's going to be 11 and 1. Now I want to make minus 1, so it's going to be minus 1 plus 1, or minus 1 and plus 1. So you could use trial and error. I personally spot this because I go, oh well, if it's plus 1 times 11, that makes plus 11, which means that the plus 11 is stronger than the minus 1, and that's why we end up with a plus there. Whatever works for you. So we've got 11x minus 1 equals 0, or x plus 1 equals 0, so we just kind of rearrange, so 11x equals 1, so x equals 1 over 11, or x equals minus 1. There's the two answers. So this says solve. Solve basically means solve the puzzle. So what's the puzzle? Well, the puzzle must be what's k. Yes, it's not in terms of x, which is what we usually see, but hey, that's okay. We've got to find the k. And yes, k is often a constant. But in this case, well, it can't be, because that's, well, anyway. So there aren't any fractions, let's deal with that. Let's deal with the brackets. That'll be 11k squared plus k. And then the right hand side stays the same. Is it an x or an x squared? Well, it's a k squared, but I still like to say in my head x or x squared. It's how I think about it. Anyway, whatever works for you. So it's definitely an x squared, so let's make equal to 0. I'm going to take the 10 over to the 11. The reason being I want it to just be positive. So I'll minus 10k squared. while I'm at it, I'm going to minus 6 at the same time. So I end up with k squared plus k minus 6 equals 0. I'm going to factorise it next. So we'll put a k and a k at the start because we want to make that work first. Then the second thing is to do the right hand side. Anyway, so that would be 1 times 6 or 2 times 3. You can try and error it. It could be minus 1 times 6 or 1 times minus 6, or it could be minus 2 times 3 or 2 times minus 3, or you might use some system. I just kind of I logic it out usually. In this case, the difference has got to be 1, so it's going to be this or this. And I want the plus to win, so it must be this one. So let's put a plus 3 and a minus 2. The only reason I could do that, by the way, is because the k was on its own. If there'd been a number in front of one of the k's, it wouldn't have been that easy to logic out. I would have had to be a bit more careful. So k equals 2 or minus 3. You could also write that as k equals 2 or k equals minus 3, just in case that's confusing, because I know I've written that a bit differently. Following my standard approach, are there any fractions? Yes. Let's get rid of the x first. So I'm going to times by x, because I don't want the x on the bottom. I'm going to make a deliberate mistake, see if you can see what it is. 1 plus 2 over 7 equals 3 over 7 times x. What's my mistake? I must times everything by x. So you've got to times the first thing by x, the second thing by x, and the third thing by x. So just to write that more clearly now, that's 1, 2 over 7x equals 3 over 7x. I've decided not to write the times sign. By the way, you might have written, say, for this bit here, you might have written 3x over 7. That's great, you can write it like that as well, it's all good. Just a different way of writing the same thing. In this case, we can get away without combining the fractions. Don't worry if you don't know what I mean. So I'm now going to times by 7 because there's still fractions kicking around, which I'm personally not that keen on at this point. I think it looks a bit of a mess. So 7 plus... Oh, well, both these remaining terms are divided by 7, so they'll just cancel. Oh, look at that. So we've got rid of the fractions. Are there any brackets? No. Is there an x? Is it an x or an x squared? It's an x. All we need to do is rearrange it until we get x equals. So let's minus 2x from both sides. That gives us 7 equals x, because we're trying to bring the smaller to the bigger number of x's. But that's the final answer. There's a tiny thing which you might be asking. You might be thinking, wait, did I have to times by 7? Couldn't I have just left them as fractions? Yes, you could have done, and if you'd done that, then this would have happened. 1 equals 3/7 x minus 2/7 x. So 1 equals 1/7 x. So in this case, you would have ended up having to times by 7, and you would have ended up with 7 equals x. It's not always the case, and definitely I didn't have to times by 7 there. I don't think so. But that was an example, I think, of kind of gut instinct, and also this thing, you kind of simplify as you go along, and at that point I was like, I'd rather simplify that, I don't really want fractions in front of the x. First thing, are there any fractions? Well, clearly, let's get rid of the x squared. That will cancel on the first term. We must multiply every single thing we can see that's separated by a plus or a minus. So in this case, we're going to multiply the 5 over x times x squared. I'm going to leave that like that and talk about the cancelling in a moment. Plus, well, 1 times x squared is just x squared. Now, you've got a 5, you're dividing by x, and you times it by x squared, which means you can just cancel the x, one of the x's on the top with an x on the bottom, because x squared divided by x is x. So that leaves me, I'll just rewrite it. I'm merely rewriting it so I can see it more clearly. Now, so that I can use my visual kind of memory, I'm going to reorder it so it looks the way it normally does. Anyway, so that's now fractions, and the brackets are dealt with because there weren't any brackets. It looks like it's an x squared because I can see an x squared. I need to make it equal to 0. Oh, it's already equal to 0. I need to factorise it. Let's have a go. First of all, I make the x squared on the left-hand side. Now I make the 6 on the right-hand side. It's either 1 times 6 or 2 times 3. You could use trial and error to work out which one it is. It's actually a 2 and a 3. Remember, if I'm going too fast, you can pause the video and then restart it once you've worked out what's going on. So that means that x equals minus 2 or x equals minus 3. Oh, that should have been a minus there. There we go. Have a go in your own time. Okay, here's my answer grid, so that's how I'm going to be approaching it. Are there any fractions? No. Are there any brackets? Yeah, let's get rid of those. 5x squared minus 10x equals 0. Is it an x or an x squared? Oh, it's an x squared. I need to make it equal 0. It's equal 0. Now I need to factorise it. Oh, wait a sec. It was already factorised. I didn't need to do it. Haha. How many of you did that? If you spotted that you didn't actually need to do anything, nice one. So in fact, just to be clear, we didn't need to do that. Completely unnecessary. All we need to do now is go, oh, it's two things multiplied together that make 0, so either 5x equals 0 or x minus 2 equals 0. So that would be x equals 0 or x equals minus 2. I'm just going to extend this briefly in case it's a little issue. You might be thinking, that's weird, I'm used to it being like x plus 2, x minus 5. In which case x equals minus 2, x equals 5 are the two answers. So this is just an extension in case you're wondering about the x equals 0. So, oh, what does it mean if it's x times x minus 5? Well, it might make it easier if instead of writing it like that, you write it as x plus 0. Because that's basically what you're doing. In which case, x equals 0 or x equals 5. So, there you go. There's a way of thinking about it that might have helped. It might be really easy for you, it depends on how you look at it. X times x is x squared, x plus x is 2x. So that's the first hurdle overcome. I'm going to spot that it's a quadratic type, so I'm going to make it equal to 0, then I'm going to try and factorise it. So I'll factorise by taking out an x, because when you try and factorise, you initially try and take out something they've both got in common. Oh, look, it's fully factorised, so we can now conclude that x equals 0, or x minus 2 equals 0, which gives the solution x equals 2. So that's the two solutions. If you spotted that really quickly, well done. You might have just immediately decided that x was 2, because there's a really neat rule for 2, which is that 2 times 2 equals 2 plus 2. So it's a pattern that doesn't exist really for any other numbers. And so you might have just spotted that, in which case make sure you got the 0 as well. And if you follow my standard approach to solving, which is to deal with fractions and brackets, then decide whether it's x or x squared, it's a relatively easy question. Show that this has no real solutions. There's going to be a few ways of doing this. I would go straight into x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. Because if we try and factorise it, it's probably not going to work, because otherwise, if it's going to work, how would there be no real solutions? Because that would kind of imply there were two real roots. If we look at this, oh, look at this, we square root b squared minus 4ac. Well, you can't square root a negative number, so if we could show that b squared minus 4ac is less than 0, then we'd show that there are no real solutions, because you know what? You can't square a negative number, therefore you just basically get math error on the calculator, or it's not possible, it can't be done, therefore there is no solution for x. Okay, let's do it. So a equals 1, b equals 3, c equals 11. So b squared minus 4ac equals 9 minus 44. Okay, right, well that is clearly less than 0. There we go, we've shown it. Not possible, and you could write a sentence if you wanted, not possible because b squared minus 4ac is less than 0, which cannot be square rooted, therefore no real solutions. Or you might write something else. By the way, You might be thinking, could I use the discriminant? You could. I'm not sure that's how you spell it though. You could use the discriminant, and if you do that, that's great, because then that must mean you know about that topic. I just thought I'd answer this in a way that would help people that hadn't done the discriminant. But yes, if you know about discriminant, just go for that. This question can really stump you if you miss what you need to do. If we use my standard approach, the first thing is to deal with fractions. You might not spot any fractions, but remember also the general rule, which is always looking for indices things or trigonometry things. Oh look, that there is x to the minus 2, which is basically a fraction in disguise, so that's x squared plus 5 over x squared plus 6, because that is supposed to be a 6, equals 0. So let's deal with the fractions, so we'll times everything by x squared, so then we get x to the 4 plus 5 plus 6x squared equals 0. Let's just reorder that so it's more familiar, because you normally go from high to low powers of x. And that will factorise, because we know it's an x squared type, it's not just an x. So if we follow our method, we get rid of the brackets, and then we go, is it an x or an x squared? We spot that it's an x squared, so we make it equal to 0, and then we try and factorise. To make the x to the 4, we need an x squared times an x squared. To make a 5, well, we could do 5 times 1. Well, actually, that's it, because it's a prime number, so let's just go with it, and presumably that's going to work. If you multiply that out, yes, it does work. So then we get x squared plus 5 equals 0, or x squared plus 1 equals 0. So that means that x squared equals minus 5, or x squared equals minus 1. So x, well, what we can say is there are no real solutions, because you cannot square root a negative number. Because what we would do next is we'd have, for example, x squared equals minus 5, and if we square root both sides, we end up with x equals the square root of minus 5. Oh, look, that can't be done. If you know about imaginary numbers, you might have come up with a solution. I'm not going to talk about that here, but let's, in general, in a lot of situations, we just say, hey, there's no real solutions. I'm just going to give the answers to this. The first one, the answer is x equals 2. The second one is x equals plus or minus 2. The third one is x equals 2. The fourth one is x equals plus or minus 2. And the fourth one is x equals 2. Now let's talk about it. How come these two are a plus or minus? Because they're even powers. And if it's an even power, even if it's minus 2 times minus 2 makes plus 2. Whereas this one here, if we tried out minus 2, went, oh, I wonder if minus 2 is a solution. Oh, look, it doesn't work, so it makes minus 2. So if it's an even power, there's 2 possible solutions. If it's an odd power, there's just the 1. So this question is worded a little bit unusually. It's asked us, when is fx equal to g of x? Well, that's what f of x is, and g of x is this. Oh look, so we just need to solve this equation. Using the standard approach. Do you know what I'm going to immediately do? Is I'm going to sling that over the other side. So I'm used to seeing the x squared on the left hand side. Minus x from both sides, minus 1 from both sides. Now I've got it equal to 0. Now I can try and factorise it. X times x is x squared. How do I make 5? Well, 5 is a prime number, so there's only one way of doing it. So that means that x equals minus 1 or x equals minus 5. That's it. So if we follow the standard solving approach, there's no fractions, there's no brackets. Is it an x or an x squared? I'm going to call it an x squared type. Obviously it's not exactly x squared, it's more than x squared, but hey, so then need to make it equal to 0 and then factorise it. By the way, there's a way of doing this with a substitution, which I will talk about at the end of the video. Initially I'll do it without substitution, because personally I tend not to bother with substitution. because I've got this really careful approach, I need to make the left-hand side first. So I need to be x to the 3 over 2 times x to the 3 over 2. I now need to make this side. I need to make a 4. And I'm just going to spot that it's going to be minus 4 and minus 1. By the way, that there is supposed to be a 3 over 2. And if you multiply that does work, which now means that one of these two must be equal to 0. This side just gives x equals 1 because I'll add 1 to both sides and then 1 to any power is just 1, so that's sorted. There is an issue with, oh wait, could it be minus 1? But if you put minus 1 in, it doesn't work. This is how I'd logic it out. I'd just say, well, minus 1 to 3 over 2, I wonder what that is. Will that be minus 1 to the half? Oh wait, you can't square root a negative. Okay, so that doesn't work. So we can ignore that one. Maybe leave that as working. So just write not possible and put it in a box. Here on the right hand side, x to the 3 over 2 equals 4, which means now if we square both sides, that will become x cubed equals 16. Cubed root both sides, x equals the cube root of 16. You might be thinking that's really sneaky because a 4, if you square root of 4 and cube it, you end up with a nice round integer. But in fact, the correct answer is a really awkward cube root. I've seen this quite a lot in questions because it really does check that you're following the approach and not just looking for patterns. So you need to actually follow the correct approach. Anyway, how might I do a substitution? Well, there's lots of different ways of thinking about it. One is that you make u equal to the smaller power. So you'd have to make u equal to x to the 3 over 2. And at that point, you can then rewrite the equation as u squared minus 5u plus 4 equals 0. A lot of people like to follow this approach because it can make factorising easier to see. And then you'd substitute the u back in. Oh look, that's just u. And then you can just basically carry on the way we were anyway. So this question has given us an equation that's in a bit of a mess, so let's tidy it up. The top is 5x, and the bottom of the fraction remains as a 3. Now let's times both sides by 3, so 5x equals 30. And then divide both sides by 5, so x equals 6, and that's the final answer. Notice I did put a little sort of trap in there. Do not do this. No, you cannot do that. Because if you're going to cancel from the top and bottom of a fraction, you can only do that if it's you can only do that if it's times and divides only, because you can cancel times and divides, but there's some plus signs kicking around in there, so you can't do it. So remember, you cannot cancel the 3's. You need to actually simplify the top and bottom of the fraction to get to here, and then you can start playing around with the fraction because you've only got a times hidden in there, and that there indicates a divide. I'm a big fan of this question, and I find it often stumps people. So it's good to kind of learn this one. If you're going to do it as a substitution, just put u equals root x. So if that's what you did, nice one. I'm going to do it without substitution, and I'm just going to spot that it can be factorised. Okay, so this is really weird. And if I put root x, what's root x times root x? It's x. Aha. Now we just need to make a plus 6, so let's put a plus 3 and a plus 2, because if we then multiply that out, yep, that does work. So now we know that root x plus 2 equals 0, or root x plus 3 equals 0. So root x equals minus 2, which means if we square both sides, x equals 4. And on this side, the square root of x equals minus 3, so if we square both sides, x equals 9. And that's the two solutions. And that might feel really strange, and if you haven't done something like that before and it feels strange, I kind of think it's a good thing that it feels strange, because there's a lot of unusual stuff happened here. At this point, I would put one of these numbers back in. Let's put a 4 back in and see if it works. Is 4 plus 5 root 4 plus 6 equal to 0? Question mark. That would be 4. Right, what's the square root of 4? Well, it could be plus or minus 2, so 4 minus 5 times 2 plus 6, is that equal to 0? Yes, it is. Okay, so it requires us to use the negative root, but as long as we take that negative root, it's okay. So there are some issues here. If you draw a graph of y against x, where y is the square root of x, we often only write the positive numbers. So depending on what kind of situation you're dealing with, if your function root x has been defined such that only the positive roots are being taken, then this isn't going to work. There's not going to be any solutions to this equation. But if you're in a situation where you are allowing, so that's like situation number 1, it kind of doesn't work in that case, or what we've just done doesn't work. But if you're going to allow a square root to be positive or negative, then it does work. Do you know what? I could waffle on about this all day. There you go. There's lots of ideas inspired by solving that equation. I consider this in principle to be a very easy question. The reason being that if we follow this standard approach, I don't think there's any real hiccups. Are there any fractions? Yeah, there is, so let's times everything by 4 to get rid of the fractions. Yeah, you don't have to get rid of fractions all the time, but I find that this universal approach pretty much solves any equation. Anyway, with caveats. Are there any brackets? No. Is it an x or an x squared? It's clearly an x squared type question. There is a power higher than x squared, but let's not worry about that. So we'll therefore make it equal to 0 as the next step, then we'll factorise it. I'm going to move everything over to the side that's got the higher power of x already, because I find it easiest to solve in that case. I'll put the equals 0 on the right hand side because then it triggers my visual memory. So my experience of answering questions in the past will be sort of drawn to the surface because it will look familiar. At least that's what works for me. I'm now going to try double brackets in here. How can we make a 12? Well, that could be 1 times 12 or 2 times 6 or 3 times 4. There's a lot of combinations to try here because one has to be positive, one has to be negative. We definitely know it's an x on each side because x times x makes x squared, and it turns out that it's minus, let me switch, minus 6 plus 2. So, and you can multiply that and check it if you like, or use your method of choice to work those numbers out. So we now know that x equals 0, or x equals minus 2, because x plus 2 has to be equal to 0, or x equals 6, and those are the 3 answers. Show that the line y equals 5x minus 11 does not intersect with the line y equals x squared minus x plus 9. Well, sometimes I like to ignore the does not and think, well, if they were going to intersect, what would I do? Well, I'd solve them as simultaneous equations. So let's solve them as simultaneous equations, and then presumably it won't work. And then we can say, oh look, they can't be solved as simultaneous equations, therefore they do not intersect. And that's what I'd write at the end, but I won't bother to save time. So I've just made y equal to y, because I know obviously in order to be simultaneously true the two y values must be the same. And using my standard approach, or probably most people's standard approach, I'm just going to draw everything over the same side because I've spotted it's an x squared. So that'll be x squared minus 6x plus 20 equals 0. And I'm not going to try and factorise, I'm going to dive straight into using x equals minus b plus or minus the square root b squared minus 4ac divided by 2a. Now what's going to happen here is this bit here is crucial. It even has a special name in maths, it's the discriminant. It's not, it's the determinant. Or is it the discriminant? Anyway, it has a special name, and I can't remember what it's called. B squared minus 4ac. Right, now, if that's less than 0, we can't square root a number that's less than 0. So let's find out what this is. A equals 1, B equals minus 6, C equals 20. So that would be 36 minus 4 times 1 times 20, which is 36 minus 80, which is less than 0. We've shown what we needed to. And that's where I would now write something like the number inside the square root is negative, you cannot square root a negative, therefore there are no real solutions for x. Therefore the two lines do not intersect. I've put this question in because it can throw people sometimes. Because like, whoa, what's going on? Where's the sign come from? Well, let's just do sine to the minus 1 on both sides. We're going to do the inverse function so that we can get x on its own. So then we need to just put that in the calculator, which I'll do, and I'll pause the video so I can do that. So the magic of video, I've drawn a graph here, and I've also put it in the calculator. What I discovered was that x is minus 5.74, that's what I got from my calculator. And then just to be sure, I drew a graph, and I observed that between minus 90 and 90 degrees, the graph of sine x, because I've used sine x as my vertical axis, will only have each value once in that range. If it carried on, oh look, if you carry on, say, a long way as to infinity, if you're going to go crazy, then there's going to be lots of solutions. But there's just this one here, and that's it for the range that was specified in the question.